Okay, can you hear me?
Yes.
So just take out your tide tables. I hope all of you have got tide tables. And see the question which is written here. You can write down on the side. We are required to find out time and height of high water, low water at boom. Port is boom, BOOM, for 24th February 1992. And from this data, find the height of tide at 1800 local time. So just write down on one side, 24th February 1992, port is boom. First we need to find out time and height of high water and low water at boom for that date, 24th February. And from this data which we'll get, we have to find the height of tide at 1800 local time. That means standard time of that flow, because we have not been given anything about daylight saving. So this local time will become the standard time for boom also. Now, sometimes they don't give you that number, but usually you are supposed to be given a name and a number both. So just in case you don't have the number, then we'll have to go to the geographical index. So this is volume 1 inside cover. So you can open up the cover, inside cover. I think in some of those books which you have got, you may not have this inside cover, whereas in the actual volume you will have the inside cover. Just behind this cover page, you will see name of all the standard ports given and the page number. So these are all standard ports. Now in this you will find no boom is written. So definitely it is not coming in volume 1 as a standard port. Now we come to geographical index. You will get it on page 423 of volume 1. So if anybody has not been able to get, then just let me know. Each volume at the end, you will have a geographical index in which by alphabetical order, the name of the port is given. And wherever the name is given in capitals, like this bold alphabets, that port is a standard port. And the page number is given. Otherwise, on the right hand side, what you are going to find is the port number now. This is not page number, this is port number. So let's see, boom is showing up here on this page number 423 of volume 1. So it is there. Boom. Where did we find? In volume 1 in geographical index. So here they have given the port number 1539 small c. So we'll see what is that small c. Now we go to part 3. Part 3 has got all those numbers given in in series only, like serial number wise. So that number we had just obtained was 1539C. So let's see if it is here in this part 3. 1539 is there as Antwerp. Antwerp is the standard port. But we have got one small C written. So they have given A, they have given B, C is not there. So that means we'll have to go to part 2. Because this cannot be calculated by harmonic constant method. So you'll have to go to part 2. Part 2 you will find time difference, height difference given on top. Whereas in part 3 you will find M2, S2, K1, O1 written on top.
Your screen is stuck, I think.
There was some signal problem. Can you see the table now?
Yes, sir. Thank you.
Yes, sir.
Okay. So see wherever on the top you see M2, S2, K1, O1 and shallow water correction, SW correction with that F4, F4, F6, F6. That means you are in part 3. Part 3 will contain all the port numbers serial wise. So when we went to the number we wanted, 1539C, 1539 we saw is Antwerp and that is given in bold letters. That means it's a standard port. But 1539C is not mentioned here. So then we look up in part 2. So here you'll find on page number 334, 1539 Antwerp. Under Antwerp, you will find 1539C, boom. So what have we learned till now? Boom is a secondary port which is having a standard port as Antwerp. So to calculate high water, low water at boom means first we have to calculate high water, low water at Antwerp. Then apply time and height corrections which are given here. Time difference, height difference, and get the data for boom. So one by one we will do. Try and understand the problem. We are given a port boom. No number was given. So we went to the geographical index. Geographical index gave us the number. So then you can come back to, it is not a standard port. So you can start off with part 2 also, but it's better to see from part 3 where exactly this port is. So we could not find in part 3. So part 2, we looked up and saw that it is given under Antwerp as a secondary port whose standard port is Antwerp. So this number is matching, this name is matching. That means you are on a right page. So how do we pick up the data? We have got time differences for high water so much, low water so much. Then for high water, height differences so much. So don't worry, time being, you don't worry about this. We'll go step by step. So first we'll find out Antwerp. What is the data for Antwerp, 24th February 1992? Because when we get the data, we'll apply time correction, we'll apply height correction, and we'll get data for boom. So till now, anybody has any doubt how to find out where that port is and then what to do? Okay, then let's go to Antwerp. Remember I told you the Antwerp is a standard port. That means it will be given in part 1 of the volume. So you will see on the left side range curve is given on page 182. Open page 182. On the left side you will find this diagram which is known as range curve because it is spring range, neap range, two curves. And on the right side you will find this data. So come to this page on the right side. This page was 182, so this should be 183. Come to this page 183, Antwerp, February and 24th. So 24th February is Monday and they have given the time of low water, height of low water, time of high water, height of high water. So low water, high water, low water, high water, time and height. Just write down this data on one side of the page. This is for standard port, Antwerp. Because we have to calculate high water, low water at boom. But boom is related to Antwerp. So first we find out Antwerp, then we'll apply some corrections to time, corrections to height, and we will get data for boom. So write down exactly the way it is given. This is data on top. You put down data for Antwerp, 24th February 1992. Okay, so now we will go to. Normally, if you are looking up tight table, just put marker pages, no, one strip of paper. Keep putting down in part 1, part 2, part 3, so that going forward and back becomes easy for you. So about 3 or 4 markers you keep, either the stick-on type, those colored papers, or you can put some 6-inch scale, but normally it slides off. The scale, when you are flipping through, that scale will slide off. So put those stick-on types markers or just piece of paper, a strip of paper you put as marker here at part 1, part 2, part 3. Put those markers. So straight away you can go to that particular page. This you don't worry, we'll see it later. Now come to this conversion. How to convert. This data you have written down 24th February 131 0.4 low water, right? Low water. 725.6 high water, then again low water and high water. Then make this table in which write standard port time, time correction, secondary port time. And put same series, whatever, starting from low water, start low water, high water, low water, high water. 131, 720, 1357, 1940. Just write down, make this table. The top one you have already written. Now make this table with standard port time, time correction applied, and convert it to secondary port time. How to get that correction I will tell you, but just make the table and put down the data. 131, 720, 1357, 1944, this data, first row, put down. Okay, so now we will go back to those corrections which we had seen in part 2. So come back to that page where we saw the corrections. See the time difference correction, height difference corrections. So come to this page number 334 and come to this boom and come to these columns, 2 columns for high water. These 2 columns are for high water under time difference. Time difference has got 4 columns. 2 columns for high water, then next 2 columns for low water. So understand this. If your high water at Antwerp was exactly 0000 hours, that means midnight, then the correction to be applied to that would have been plus 1 hour 25 minutes, and that time of high water will become time of high water at boom. Okay, so midnight, suppose Antwerp time, it was high water. So boom will have high water at 125. Similarly, if 12 o'clock exactly noon time, there was high water at Antwerp, then you will have to add 1 hour 25 minutes to get high water at boom. That means it will become 1325. So add 1 hour 25 if the time was exactly midnight or noon. Similarly, if the time was exactly 5 o'clock, correction is 1 hour 10 minutes. 1700, the correction is 1 hour 10 minutes. In between, you'll have to go diagonally across and then you will get the answer, because we have to go 00 to 5 o'clock like this, 5 o'clock to 12 o'clock like this, 12 to 17 like this, 17 to 24 like this. So if we want for 1800, we'll have to check for 1700 and we'll have to check for 000 hours and then get 1800 in between. So 00 to 5 o'clock will go interpolation like this. 5 to 12 intersection will go like this, sloping. 12 to 17 again horizontal. 17 to 2400 any time you'll have to go diagonally. So horizontally, diagonally, horizontally, diagonally. Only interpolate. The time has to come somewhere on this horizontal or diagonal line. Don't take 6 o'clock as between 12 o'clock and 000 hours. No. 6 o'clock will come between 5 o'clock and 1200. 1300 will come between 1200 and 1700, because the time always moves like this. 0 to 5, 5 to 12, 12 to 17, 17 to 24. So whichever time you want, interpolate along that horizontal line or diagonal line or horizontal line or diagonal line. Any doubt in this? Have you understood?
Sir, could you please repeat this again?
Okay, see, you asked me 100 times, so no problem, but you must get it right. These two columns, the first two columns coming under time differences are to be applied to high water time only, because this is time correction. So high water time, if it was exactly 0000 hours written for Antwerp, then the correction becomes plus 1 hour 25 minutes for boom. And if the time was exactly 1200 hours at Antwerp for high water, remember this is for high water, then the correction becomes 1 hour 25 minutes. Similarly, next column says if the time was exactly 5 o'clock, correction is 1 hour 10. If the time was exactly 1700, correction is 110. Now let's say we want for 6 o'clock morning. So 6 o'clock morning will come between 5 and 12. Remember the time moves like this: 0 to 5, 5 to 12, 12 to 17, 17 to 24. So 6 o'clock morning, you'll have to check for 5 o'clock. 5 o'clock is 1 hour 10 minutes. Then go to 12 o'clock. 12 o'clock is 1 hour 25 minutes. That means it has increased by about 15 minutes. In how many hours? 7 hours. So 7 hours, it has increased by 15, almost 2 minutes per hour. So 5 o'clock is this. So 6 o'clock will be 112. 2 minutes per hour approximately. You'll have to add 110 and moving to 125 means it will become 112. See if you all can get for 6 o'clock, your answer should be 1 hour 12 minutes are to be added.
Can you repeat the adding part, sir? Only adding part.
Okay, see 5 o'clock, the answer is plus add 1 hour 10 minutes. And 12 o'clock, if you have 12 o'clock high water time, then the answer is add 1 hour 25 minutes to the time of Antwerp. Whatever high water time you have at Antwerp, add 1 hour 25 if 12 o'clock is the time of high water at Antwerp. If 5 o'clock is the time of high water at Antwerp, you have to add only 1 hour 10. So 5 o'clock high tide, 1 hour 10. 12 o'clock high tide, 1 hour 25. 6 o'clock will come where? Between 5 and 12. So from 1 hour 10 minutes, we are moving towards 1 hour 25. How many hours have occurred there? 7 hours. And how much is the difference in time? Approximately 15 minutes. So we can say for every hour, there is a 2 minutes increase after 5 o'clock. So 1 hour, if I want to move beyond 5 o'clock, means I have to move towards this by 2 minutes. So how much will it be? 1 hour 12 minutes. Another to 7 o'clock will be how much? 1 hour 14.
It is coming 1 hour 12 minutes.
Okay, that is okay. I told you your value should come close to 5 minutes maximum. Maximum error in time is 5 minutes. So that is okay. If you are getting whatever decimals you are getting, you can use, but you can't write time as 1 hour 25 minutes 30 seconds. So round off to the nearest minute. Okay, time always round off to the nearest minute. Don't write in seconds. Now, suppose I want time for 3 o'clock morning. So how will you get? High water is 3 o'clock at Antwerp. So what will be the correction for boom? 00 and 0500. 00 is 125. 5 o'clock is 110. That means it is reducing. The correction is reducing.
0116.
0116.
So you all are getting that now?
Yes, sir.
So sometimes you have to increase, sometimes you have to reduce, but only between two values. Sometimes you'll be increasing, sometimes you'll be reducing, but the answer will only be between these two values because you've got only two columns for high water.
So it is 0 plus 0122 or 26.
This is plus 125.
No, sir, for 3 o'clock, sir.
For 3 o'clock, okay. 3 o'clock means what? For 5 hours, the difference is 15. So 1 hour difference will be 5. 3. For 1 hour difference will be 3. So 3 o'clock means what? 3 hours. 3 threes are 9. So 25 minus 9.
Okay, sir.
So you've got 1 hour 16 minutes. You have got.
Yes, sir.
Okay. So this step you must understand and be absolutely clear. These two columns are for high water, but when you are looking at low water, you will have to use these two columns. So now let's go back to our question where we had the high water at what time? 1357 and 1944. The data you have written, no?
Yes, sir.
To start converting that data now, high water time. So first data is low water, 131. So low water means you'll have to use these two columns. So 131 will come between 00 and 0600. We'll do one by one. So first you convert 1 hour 31 minutes low water. So it will come between the 0000 and 0600. That means you will be moving little less than 155. So 131, 1.5 hour.
Sir, is it 0154?
This one is 0155, but you will get answer as 0154.
Yes, sir. Answer 0154, sir.
Correct. 0154 because it is reducing, no? So just write down correction for low water 0131 will be plus 0154. Don't forget to write the sign plus. So what will be the time at boom for the first low water? 325. Add 0154 to 0131. What do you get?
0325.
So 0325 will be the first low water time at boom. Now, if you want, you can go to next low water and then come back to high water. There's no problem. You can finish up both the low water first and then write for high water. So low water is at 1357. So again, convert 1357 will come between 12 and 1800. So 1200 so much, 1800 so much, 1357, what value you are getting. So see if you are getting 1 hour 53 minutes approximately.
Yes, sir. 0153 plus 015.
So then that next low water time will become 1550.
Yes, sir.
So we just wait for others to catch up. Meantime, you can do for high water. So I'll go back to the table and you can see for yourself. So you should be getting these corrections now. 1 hour 54, 1 hour 15, 1 hour 53, 1 hour 14. See if you all are getting this, and then you have got the time and time at secondary port for low water and high water. Okay, so we'll take a 5 minutes break and then continue. Okay, you all come back.
Yes, sir.
So anybody who has not got this data for boom secondary port, low water will occur at 325, high water at 835, low water at 1550, high water at 2050. So exactly like this data for Antwerp standard port, we have got data for secondary port as far as time is concerned. Now we have to get the height.
Excuse me, sir.
Yeah.
Sir,
For high water 1944, we are getting the correction 0116.
0,
yes,
1,
sir,
1,
that is correct.
0, 1,
Yes,
1,
yes,
5.
016 RS.
Okay, take it. No problem. Take it as 1/6 if you are getting. Because I told you, finally, even if you are getting within 5 minutes, there is no problem. So sometimes, yes, it might be plus minus 1 or 2 minutes. It doesn't matter. You write down whatever you have got, you write down. Okay, now comes the part where we have to get the height. What will be the height? We know the low water height is 0.4, high water is 5.6, low water 0.2, 5.3 at Antwerp. But we have to apply some correction to this to get the height at boom. So how do we do it? You have to remember one thing, tide tables, when you see standard port heights, this data, it includes seasonal correction. Something like, I'll give you an example. You all know Maruti has got a factory at Gurgaon. And Maruti cars are being sold in Delhi, they are being sold in Mumbai. Suppose factory price was 1 lakh and Delhi applies a tax of 10%, Mumbai applies a tax of 20%. So you can find out what is the price in Delhi and what is the price in Mumbai. So Delhi it will be 1,10,000, Mumbai will be 1,20,000. So if I give you a price of a car, Maruti car in Mumbai, can you get price in Delhi based on 10%, 20% tax?
Yes, sir.
How will you do it? First, Mumbai price, remove the tax, Mumbai tax, that means Maharashtra tax. You will get factory price. And factory price, you apply the Delhi tax and then you will get Delhi price. So that is what we are going to do here. Standard port height has got seasonal corrections included. What is seasonal correction? Continuously winds are blowing onto shore like northeast monsoon, southwest monsoon or some other winds. They are seasonal. So for a few months they are blowing in this direction, other months they are blowing in different direction. They make a change in the height of tide. So that is known as seasonal correction. So this seasonal correction, if you remove from the standard port height, then you will get uncorrected at standard port, something like your factory price. So get uncorrected, then apply height correction. And you will get uncorrected at secondary port. Then apply seasonal correction. Add. Remember the Delhi tax was added. Mumbai price, remove Mumbai tax, factory price, then add Delhi tax. So same thing we are going to do here. Standard port, we are going to remove seasonal correction for standard port. We will get uncorrected height at standard port. We are going to apply the height correction. Then we will get uncorrected at secondary port. We are going to apply seasonal correction, add of the secondary port. Now we have got height at secondary port. So try and understand this sequence. Standard port height given, that you have already written down, it is given. Seasonal correction, I'll tell you how to get. You have to subtract. What will you get after this? Uncorrected height at standard port. So 0.4, 5.6, 0.2, 5.3. These are uncorrected height of low water and high water at standard port. Now, what is the correction to be applied to convert to secondary port? That is known as height correction. So apply that height correction and you'll get uncorrected height at secondary port. Now you add seasonal correction for secondary port. You will get height at secondary port. So try and relate to that example of that car I gave you. Procedure is very much similar. First remove, apply correction, add seasonal, and you get the answer. So now how to pick up these values, I will show you. So any doubt in this process, what we are doing, the data given for the standard port includes seasonal correction. So remove the seasonal correction. What do we call that data? Uncorrected data for standard port. Now we apply height correction between Antwerp and boom. What we get after this? Uncorrected height at secondary port. Then we apply seasonal correction. Why? Because we don't know which month we are talking about. So seasonal correction are different for different months. So what we are doing is for a particular month, what will be the correction that is coming in seasonal. So this is the average value for the year. This is the corrected value, correction to be applied. Now you get the height. So see the sequence and let me know if you have not understood any part of this sequence. Standard port, seasonal correction, standard port, subtract. Then you get uncorrected height at standard port. Apply height correction. Where to get, I will show you. Then when you apply this height correction, what will you get? Uncorrected at secondary port. Now add seasonal correction secondary port. What will you get? Height at secondary port, boom. So if there was a tight table made for boom, it will contain these heights, which are including this seasonal correction. Just let me know if anyone has not got the general idea behind this. Now see this height differences. We are looking at height differences. So this will be the correction to be applied to height. But what about seasonal correction? So seasonal correction for 1539 and 1539C. So at the if you don't see here, you have to change to the next page. Can you see that page after this 334, say 333 or 335? Just see at the bottom, some seasonal corrections are given.
Yes, sir.
So for that port number, you can pick up the seasonal correction for February. See, you'll get 0.0 for Antwerp. That page is not here.
Yes, sir. Yes, sir.
Okay, so then the data you start filling up as per this table. First write down standard port heights. So low water was 0.4, 5.6, 0.2, 5.3. Write down this first row. Then you put down seasonal correction for Antwerp. That's standard port. So that is 0. So minus. Put the sign minus because we have to remove. Minus 0.0, minus 0.0 for February.
Sir, in the seasonal corrections, there are some port with seasonal value with some sign minus and plus. So, will that affect this, or if there is plus, we have to use the plus only?
So here, remember, when I say minus, you are supposed to subtract with that value inside the bracket here. Okay. So put the value in the bracket, outside you put minus. So minus and minus will become plus.
Yes, I got it.
Okay, this minus sign is to be kept always. And then inside the bracket, you put down the value, whatever it is, plus or minus. So if your correction is showing as minus 0.1, so minus and minus will become plus 0.1. So what I'm saying here is you subtract the correction with the sign. Put it inside a bracket, plus minus whatever you're getting, put it inside the bracket.
Yes, I understood.
So now you go to the next one. What have you got uncorrected at standard port? So the same value you're getting because it was just 0. Then we come to height correction. This I'll show you how to get. Meantime, you can write the seasonal correction for boom. So boom is also 0, 0, 0, 0. But don't forget to write plus. And again in the bracket, it will become plus minus correction. Now comes the main part, how to get this height correction for 0.4 as low water. Now come here, low water is these two columns. High water is these two columns as far as height difference calculation is required. So height difference, if you want, first two columns of a high water, you can see those two alphabets in between, high water, then low water, basically for neap and spring. So if the height is 5.8, the correction is minus 0.2 for high water. And high water, if it is 4.8, the correction is 0.0. In between, interpolate, and beyond this, extrapolate. So remember, this is the only place where you are allowed to extrapolate. So any value, height of high water coming less than 4.8, extrapolate. More than 5.8, extrapolate. In between, interpolate. So we have to see for our first high water. So first high water, how much we have got? First is low water, no?
Yes.
How much is that value of that low water?
Minus 0.24.
So minus 0.24, write down whatever you are getting, you write down. And next, complete the other low water also same, minus 0.2 something. So you'll get approximately these values. Just see for yourself, are you getting close to this? Minus 0.2, minus 0.2. The first one is low water. This is high water. This is low water. This is high water.
So do we have to round off the values to 1 digit, or is it okay to keep it to 2 digits?
No point keeping it 2 digit. Round up to 1 digit only is better.
Okay, sir. Thank you.
Because final answer is supposed to come within 0.15 meter. That means 15 centimeters, and you get full marks. So more digits you keep, means more chances of error. So round off, better to round off only.
Okay, sir.
That is why I'm saying your answer, my answer may go out by 0.1, sometimes 0.2. because at 5 minutes and 15 centimeters is from the actual value. So that window is quite large. Within 15 centimeters of the actual value means 15 centimeters in addition, 15 centimeters less also. So for high water, you check 5.6. -5.6 is almost -0.2 only.
-5.6 is coming -0.6.
So are you getting close to this -0.2, -0.2, -1 approximately?
Yes, sir.
Yes, sir, we are getting.
So now just apply this corrections and get this height at secondary port. We have already got the data of height at secondary port now. After that, write down data for boom. This is what question had asked, no? Write down the data for boom 24th February. So we have got the time, we have got the height. Okay, half the question or main part of the question is complete. Now we have to do the other one. Any doubt?
Sir, this seasonal correction for secondary port is the same correction we have to take.
Seasonal correction for secondary port is for the port number. So secondary port, you see 15, what was that number we had got? One has got that small c. One has got that small c, one has got only 1539. So this is 1539. See the number 1539. This is 1539C. So check up in that bottom of that page. If you find different given for 1539 and 1539C, then you have to take those different values. If the same is given, then use the same value. So can you see any correction, seasonal correction for 1539C?
No, sir. There's only written 1534 to
0.0.
1571.
So that means it is included in that, no?
Yes, sir. 0.0.
So you take that only.
Okay.
Only thing, remember, even if it is 0, don't forget to put the sign which shows that first it is to be removed and then it is to be added. So don't forget to put this sign. Can you see this sign minus? First you remove, apply, then add. When I say remove means minus, and inside the bracket you write down the correction. Correction like you saw, some of them are plus, some of them are minus. So inside the bracket, suppose it was minus 0.1. So bracket minus 0.1. Minus and minus will become plus. So this is only indicating minus and correction inside bracket. So till here, you let me know if anybody has a doubt how to get the data, time and height at secondary port. So next part is 1800. They are saying what is the height of tide at 1800 at boom. So you can see 1550 is 0, 2058 is 5.2. So 1800 will be definitely between 0.0 and 5.2, and it's a rising tide. That means left side of the curve. So try and understand 1800 between this low water and high water. It is a rising tide. So now we go to the curves. So can you see that curve on the left side of your part 1 for Antwerp?
Yes, sir.
Now this data I've written for you here. 1800 if I want for boom, 1550 is 0.0, 2058 is 5.2, range is 5.2. Antwerp same time, 1357.2, 1944, 5.3, range is 5.1. Now what did I tell you how to start filling up this curve? Low water height, what is it? 0. See here 1550 0. So put the mark at 0. And high water height, how much is it? 5.2. Put the mark at 5.2 and join by this sloping line, the blue line. So just join this low water height, high water height. Okay, it's not starting from 0, it's starting from low water height. That low water height is 0. So this part is simple, straightforward, sloping line. Then what did I tell you? In the middle, you write high water time. So inside this box, you can put 2058. See this time, 2058, high water. So write down here in this box. Inside the box, you can write 2058. Then 1 hour you subtract 1958, 1858, 1758. Okay, so 1758, 1800 is almost close. So take that point and draw a vertical line, that red line. Draw that vertical line at 1800. Now this vertical line cuts the spring curve, the bold line cuts spring curves here at this dot. And I put 5.5 here. That means that range is 5.5. See the spring range 5.5 written right hand side top of the page. So put down this black dot is for 5.5. Intersection of this vertical line with spring curve is 5.5. And intersection of vertical line with the dotted curve is 4.0. See neap. Now the interpolation between these two neap and spring has to be done by this range, okay? This standard port range, not secondary port range. Interpolation between a spring curve, neap curve has to be done with standard port range, not the secondary port. Because this curve is for standard port, this curve is for standard port, so interpolation also should be for the range of the standard port. So where will 5.1 come between this 4 and 5.5? So you can find out with millimeters or approximately visual also you can put a dot, or you can check how many millimeters make up 1.5. So 1.1 will be how many millimeters? So from 4 you come down so many millimeters. So get that point 5.1 between this. Why 5.1? Because that is the range at standard port. Okay, so try and measure that. Measure it in millimeters if you want. From the dot at 4 and dot at 5.5. This millimeter is the difference is 1.5. So 1.5 represented by so many millimeters. So we want for 5.1, that means 1.1. So millimeters divided by 1.5 multiplied by 1.1. See how much you get in millimeters.
Sir, can you tell about the green line, sir?
Okay, have you got this 5.1 on this between these two dots 4 and 5.5 interpolation or approximate measurement? Then from that point 5.1, suppose it was say 4.7, that means exactly half, no? 4.7 would have come exactly midway between 4 and 5.5. But this is slightly more than that. So from 4 you have to come down more. So I have come here. This is my position for 5.1. From here I draw the green line, horizontal line. Where it cuts the sloping line, I drop it down or I can take it up and read the answer. So the answer here is 2 meters. Height of tide will be 2 meters at 1800 hours.
So, but why we are taking range 5.1 at boom the
Yeah, correct. See, the problem is we are using this curve which belongs to standard port. So spring range is made for standard port 5.5. Neap range is made for standard port 4.0. So you're using these two curves which are using range for standard port. So don't you think interpolation should also be done for the range of the standard port? Remember, this curve is not for boom. This curve is for what, which place? Antwerp. So you are using spring of Antwerp, neap of Antwerp. So interpolation also should be between the range of Antwerp, no?
Okay, so we'll take the approximate time range between Antwerp because the times and heights are different.
No
right?
approximate, no approximate, because this is high water, low water always, no? High water, low water, or low water, high water. So this is straight away. That
Just
range
because
is.
boom is in the evening, we are taking the evening ranges. So in Antwerp also we'll take the evening range.
Yeah, correct. Whichever you had used, no? You have used only two of them to convert to boom. So the same two you use.
Okay.
Okay, because I used 1357, 1944 and converted with to time at boom. So whatever was converted and became 1550 was 1357. So take this, and 2058 came from 1944. Take that.
So then this 5.1 we are calculating for the time 1800 or standard time.
No. See, don't get confused. This one is low water. Okay, read your tables. 1357 is low water and 1944 is high water. See your table which we had made for Antwerp first. So
Yes, sir.
the range is difference between high water, low water here. So we know low water height is this, high water height is this. So range will be the difference. Range is always difference between high and low water. Okay,
Okay,
that is why
sir.
we call it range of tide. Range of tide means how much the water will vary up and down. Okay. So low water and high water. The water will always remain between low water and high water. It cannot go below low water. It cannot go above high water. So that is the range. So the range means the water will go up and down by how much? So uppermost position is high water, lowermost position is low water. So the range will be what? High water minus low water. So don't you think the range will be this high water and low water difference? Low water height means what? The water will not come below this. High water height means the water will not go above that. So what is the range? Difference between high water and low water? So are you all getting that answer? 2 meters approximately?
Yes, sir. 2.1.
So congratulations, you have completed your volume 1 secondary port intermediate time. If you want, I can send you this sheet for reference if you like.
Yes, sir.
Sir, could you explain the red line part once again, sir?
Okay, see this curve, the middle part of this curve which represents the high water, it's written high water in the middle part. You put down the time of high water. So the time of high water we had got 2058 for boom. So write down 2058 in that box. Then you keep reducing 1 hour if you are moving this side. Keep adding 1 hour if you are moving this side. So we are moving to left because we want 1800. No? So 2058 is this one, then 1958, 1858, 1758, 1658. This will become 1558. Which time we want? 1800. 1800 will be slightly to the right, 2 minutes to the right of this middle line, which is showing -3. So slightly to the right, you draw this red line vertically. It will intersect this spring curve here, that black dot, and this neap curve here at this black dot. Spring is given as 5.5. See here, spring given 5.5. So write 5.5. And neap is given 4.0. So 5.5, 4.0. But what is our range? Our range we have to use for standard port for interpolation. Because 5.5 belongs to what? Standard port. 4.0 belongs to what? Standard port. So the range we want also should belong to standard port. So we don't use 5.2, we use 5.1 for interpolation, only for interpolation. Because this is standard port, this is standard port, so range also must be standard port. Then you get the 5.1 and then draw horizontal line, green line. Where it cuts the blue line, you drop it down or you take it up. Answer is same.
Okay, sir. It's understood, sir.
Okay, then thank you.
Sir,
Yeah, tell me.
and in the middle section, there is factor 0.1, 0.2.
This factor means if you take this, suppose this is 0 and this is 5.2. So 0 to 5.2, the difference is 5.2 in this case, but otherwise low water can start at 1 meter also. So here the difference is 5.2. So this factor tells you like your factor is coming, that intersection point is coming, say 0.37, approximately 38. So 0.38 of 5.2. So low water, you add that and you will get 2 meters. So that is another way of doing it. But this sloping line is quite good. If you don't want to use sloping line, then you can use the factor method. Because you'll get the same answer approximately. See, this is, where is this point coming up? This point is coming up close to 0.38. So 0.38 of 5.2, that is the difference between that low water and high water. So how much you get?
1.97.
So it's close to our answer, no? 2.
Yes.
So you can use factor if you like, but the sloping line is much better. Straight away you get answer. Otherwise you can use factor.
Thank you.
Okay, thank you.